Okay, so lesson 11.4. We have simplified these rational expressions. We have multiplied these rational expressions. We have divided these rational expressions. So now it is time to add and subtract.
Why do they do it like that?
Huh?
Why do they do it like that? Usually it's like you do adding and subtracting first.
Well, I feel like adding and subtracting is probably the harder one to do. So, okay, so what has to be true in order to add and subtract rational expressions? In other words, what has to be true to add and subtract fractions?
It has to have the
Same denominator.
Okay, has to have same denominator. So notice, today is part 1. And part 1, we are doing the problems that have like denominators. So as you scan through this whole page of examples, the common denominator is already there. Okay, so we'll save for tomorrow when we have to get a common denominator. Now, I just have one homework on this topic. So I think about half of it will be doable tonight that has common denominators. And then the other half will be doable after I teach tomorrow. Okay? So, you want me to go back to the basics here? Give you a basic, example here?
Sure.
We go back to the basics. If I would have asked you in, say, I don't know, 6th grade, 5th grade, what is 2/7 plus 3/7? 5/7. And why is it 5/7?
Because you just add the numerators and keep the denominators.
Okay, you just carry the same denominator over, we add the numerators, yes? Okay, so that's your basic elementary example there. Okay, example 1. 2 over 5a plus 1 over 5a.
3 over
5.
Keeping the denominator of 5a, and 2 plus 1 is 3. Now, big question is going to be today, does it simplify? That's going to be our big deal. And in this case, we don't have to worry about a factoring. 3 over 5. 3 over 5 does not simplify, so I agree. 3 over 5a, final answer. If only they could all be that easy, right? Okay. Next example. 7p over x plus 4 plus 3p over x plus 4. Thoughts?
Sorry, I just saw the math joke and it's so dumb. 10p to the second. Maybe.
Not quite.
No, 10p.
7p plus 3p, so 7 of something plus 3 of something is going to be 10 of something. 10p over x plus 4. It would be 10p squared if we were multiplying them.
Yeah.
But we're just adding.
I realized that too late.
So, okay. The question is, does anything reduce?
No.
Okay. And that's correct. It does not. Let me comment here. X plus 4. X plus 4, that x and that 4, you sometimes hear math teachers or whatever talk about those are married together.
Yeah.
Because they're added. So, in order to cancel anything from the denominator, you'd have to be able to cancel the entire factor x plus 4. Okay? So, I know because what some people might say is, oh, well, 10 and 4, they both have a 2. Let's cancel, divide out a 2. But it would have to be in every factor. So, this just stays 10p over x plus 4. Okay, next. 2a over 3a minus 4 plus 3a over 3a minus 4.
5a over 3a minus 4.
Okay. 2a plus 3a is 5a, keeping the denominator of 3a minus 4. Same question I'm going to ask all day long. Am I done? Or does it reduce?
It does reduce.
I don't think so.
No.
The next problem will, though.
No, it does not.
Yeah.
Okay, so, and here's the deal. The common mistake is, oh, I can cancel an a.
Yeah.
But in order to, this, on the denominator, there'd have to be a in both parts. Okay, the denominator has 3a minus 4, so that minus kind of marries them together. The only thing you can cancel from the denominator is the factor 3a minus 4. Unless 3, 4, and 5 all have something in common we can divide them by. Okay, we can't just cancel the a from one of the bottom pieces. Okay? 2 over z plus 3 minus 7 over z plus 3.
-5 over z plus 3.
Okay, so first of all, did we all catch?
Then minus.
It is subtracting this time instead, isn't it? So 2 minus 7, negative 5. Keep the denominator as is, z plus 3. Does it cancel or simplify?
It can simplify. Can it?
If it could simplify, there'd have to be something in common in all the terms.
Yeah.
So there's a z plus 3.
Can you please come to the high school office? Ava Bowman.
Oh.
That denominator again, there'd have to be a factor of z plus 3 to cancel with it.
That's the final answer.
And that is the final answer.
Okay.
Okay, moving along. 9 over 2y plus 4 minus 5 over 2y plus 4.
4 over 2y plus
4 over 2y plus 4.
2.
Hmm.
Yes.
Okay, so, and there's a couple different ways we can look at this. Michaela, you're seeing everything divides by 2, yes? So one option, and then I'm going to show two different options here. So if we divide everything by 2, 4 divided by 2 is 2. 2y divided by 2 is y, plus 4 divided by 2 is 2. That's probably the quicker way to get to the answer here. And that is your answer. I'm going to show it another way, though, because there are reasons you need to be able to think about it the other way. And by the way, I'm not canceling these 2's that are left because
There's not a plus 2 on top of the y right there.
yeah, there's not a 2 with the y right there. Okay, so if we would have continued going across this way, the denominator of 2y plus 4. What do 2y and plus 4 have in common? They have a 2 in common. So the other option we could have thought about this is we could have thought of factoring out a GCF in the denominator. Because factoring is the thing we need to think about today. Okay? So if we factor out a GCF of 2, 2y divided by 2 leaves me with y, plus 4 divided by 2 leaves me with 2. And the idea now is now that this is 2 times y plus 2, you could cancel this factor of 2 with a factor of 2 on top. Okay? So we could think of this as 2 divided by 2 is 1, and 4 divided by 2 is 2. And so then when that happens, we end up with 2 over y plus 2, which, it just so happens is the same answer we got last time. Okay? So on a problem like this, I don't care which way you go. They're both good, they both work. The difference is there are times when you have to be able to factor. Okay?
Sorry.
Do you understand that up there? Didn't even think about that for this class.
It's just making me laugh, just something about it.
Well, if we side note for a moment, other than the fact it's just a stupid meme, but, so, the square root of a negative number.
It's nothing.
Well, it doesn't exist in real numbers. We learn it in Algebra 2. And the square root of a negative number is I. And so, okay, so the square root of 16 is 4. The square root of the square root of a negative number makes it an I.
So 4i.
So 4I.
I figured.
And so he's calling the other person 4 eyes.
I think it's maybe less funny now that I get it.
Oh, sorry. We kept looking at it and laughing. I was like, well, maybe.
This little hair and the.
And I do think
How poorly drawn.
imaginary numbers are moving to the Algebra 1 curriculum, if I recall what I saw. But right now, Mrs. Rogers and I still teach them in the Algebra 2 curriculum, so, you know. Okay. Moving on. It's only, yeah, I don't know. Different levels of funny there. Although I know last period some people were, what's his shirt say? Which, I don't know the points of the shirt, so.
Yeah. So,
Math Grant, and the other guy has a skull and crossbones. Who knows? Okay. 3 more examples, maybe only 2. We'll see. Might only do 2. Okay. 9n minus 3 over 10n minus 4 minus 3n plus 5 over 10n minus 4.
It's a mouthful.
It is, isn't it?
6n plus 2.
Half right.
Well, no, negative 3 plus 5 is positive 2.
But it's not negative 3 plus 5. Okay, so let's look at this one. This problem is a subtraction problem, yes? We know our common denominator is going to be 10n minus 4. Now, on top, it's 9n minus 3. And then realize we are subtracting the whole second fraction. So you are subtracting the quantity 3n plus 5, which is why I just wrote it in parentheses. So that's where I warn you have to be careful. Obviously, and I don't know, maybe it'd be easier if I wrote it as it's still 9n minus 3, but then we're going to be subtracting 3n, which you got, and what else are we going to have to do? Subtract 5, not add 5. So you have to remember that subtraction sign goes to everything that follows after it. So 9n minus 3n, as you said, was 6n. Negative 3 minus 5 is negative 8. Still over 10n minus 4. Okay. Think factoring. Think GCFs. Is there GCF on top?
2.
Okay, 6n and 8 can go divide by 2. So I'm going to factor a 2 out front. 6n divided by 2 is 3n. Minus 8 divided by 2? 4. Okay. Denominator. Is there a GCF on bottom?
Oh, no.
What do 10 and 4 divide by?
2. Jeez.
2. So, 10n divided by 2 is 5n. Minus 4 divided by 2 is 2. So I have 2 times 3n minus 4 over 2 times 5n minus 2. What can simplify?
Something.
2.
The 2's? Yeah. A factor of 2 on top can cancel with a factor of 2 on bottom. Because it's 2 times the rest, we can do that.
And if I was right, I was just.
Guess or not, it was right, you know. What you cannot do, the -4 and the -2, you can't cancel those because they're being added or subtracted. Okay? The -4 is married to the 3n, the -2 is married to the 5n.
That's what starts this.
Okay, so what remains as a final answer?
3n minus 4 minus 2.
3n minus 4 over 5n minus 2. Okay. Next problem.
7 plus 3 Q.
So again, notice it is a subtraction, right? Denominator is going to be
Q squared plus minus.
q squared minus 4. Okay, what are we doing here?
Subtracting. That's very good.
Subtracting. So 7q minus 6q is
1Q.
1q. Can I just write q?
Yeah.
Okay. Then what else do we do?
-3 minus -5.
Good. Okay, so I was just writing it down here this time. It's -3 minus -5. I say keep, change, opposite. Keep, change, flip. What I don't know what everyone, learns these days.
6 in my head.
And -3 plus 5 is 2. And what kind of 2 is that? That's a positive 2. So then I have q plus 2 over q squared minus 4.
With the Q plus 2, you can and okay, all of it you can take away Q.
Not exactly.
I don't know.
Okay, we have to think, because that q plus 2 are married, and the q squared and the minus 4 are married, we have to think more in terms of factoring. Okay, now, q plus 2 is just q to the first, so unless there's a GCF, there's no factoring. No GCF, no factoring. Q squared minus 4, we have factored before.
Okay.
Q squared minus 4, it's what I call the difference of two squares.
Oh no.
It factors into two parentheses.
Sorry.
What's q squared break up into?
Q and Q.
Q and Q. What multiplies to be 4? Or in other words, what's the square root of 4? 2. So this is going to be 2 and 2. How do you get it to multiply to be a minus 4? One positive and one negative. So now I have a q plus 2 and a q minus 2.
That was just great.
So what just randomly happens to happen here?
You get rid of Q plus 2.
A factor of q plus 2 in the denominator cancels with a factor of q plus 2 in the numerator. Now, if everything cancels in the numerator, what officially remains?
Q plus 2.
But if the q plus 2 cancels, 1 remains on top, yes? So I end up with a 1 on top and a factor of q minus 2 on bottom. Okay? So the factoring is important. You have to be able to factor. It's Monday, I didn't think to look in the homework, and I don't remember exactly what kind of factoring there is in the homework. You could see some product in some. I don't know. Do I do this next one or do I not?
I wrote not.
Okay. And I will say, if you run into product of AC factoring, we need to do this one. But I don't feel like I put product of AC in there.
Okay.
But I can't be for sure. Okay? So, what I will say is go ahead and get started on the homework. You can't do it all, but go ahead and do the ones that already have common denominators. And then tomorrow we will attack the ones that don't have common denominators. Or if we get time, we could even start today, but that's not necessarily my plan. Oops, not moving too. Dang it, I'm struggling here.
Sorry.
No, it has nothing to do with you.
No, I'm just cracking myself up today.
Lesson 11.4 in Math Excel. And I guess I should say begin, because you can't finish it yet.
Okay. Mr. Kevin